Now in this lecture we are going to take a small detour in order to equip the native array with pattern matching, and we are going to do that in order to be able to use it together with the maybe in our next example. So I will go ahead here and display what I'm going to do. So my end result will be, if I have an array like this, I want to have a match with method that will take inside an object literal that's pattern like, and it had an empty case where we do something if the list is empty, and if it's not empty then we have this case concat. We can call it in many different ways, but there is a concat that takes a first argument that is a single value, and the rest, which is the rest of the array. So this is like splitting the array, if it's not empty, into the first element and the rest, and we want to do something with that. So I want here to go and write array prototype match with, and it's a function, and this takes a pattern. So the pattern is this object literal, and we want to call that with so here if this len is 0, then return the pattern empty. Else here we are going to return the pattern concat, and inside the first will be the first element of the list. So here I will just the shift, and the shift just returns the first element and then it modifies the list. So at this point the this, which represent the list, it's the rest of the list. So this is valid here, and what we're going to do here, maybe in order to display, let me first run the console log, maybe here just to capture the value and see what's inside. Okay, now we can run that, and you will see in the case of the full array here we hit this breakpoint inside the concat case, and the value is the first value of the array, the head, and the rest is the rest of the array. And also we can try to get the empty case by giving an empty array here, and we hit the empty case. So now, for example, I can go I will go real fast here and implement a recursive method to, I will call show, that will display the array. So let's say that this is an array, right? And we use pattern match, and I will go and copy this, and in the case where it's empty we want to print, let's say that this will return a string. So the case of the empty we want to return, I will return here something like that, and in the case of the concat we are going to return, or maybe I remove that. Now for the concat case I will return a string, and inside I'll have parentheses, and I will have here the value, And in the second I will add the comma, and here is the recursive part. So I have the rest of the list here, and I want to return this as a string, so I'll go and use rest, and I assume this is correctly implemented, so if we do that, this should return a valid string. So with this extension here, we should be able to write something. We can have a list and write so, and this should return a single string in our preferred format. So that was a recursive definition of the show using pattern matching on the native list. This is a nice way to write recursive definitions for list and for other algebraic data structures. You can see more in the book, but also now, for example, we can go here and create another extension method. This one I will call first or none. I will call first or none. What I'm going to do next is I want to write a recursive definition on the list, on the native array, that will take a predicate and search the list. If it finds an element that makes the predicate true, then it will return a sum with the value of the array element, and if there is no element, it will return a none. So what I'm going to do here is I will have something that's called first or none. So that will return a maybe. In case of match with, if we reach here, then probably there is nothing, and inside we'll pass a predicate. The predicate, it's just a lambda. It's a lambda that takes a value and returns true or false. So if it's an empty, then we return a new none, because we assume that we didn't find anything up until there. So that's a none. And if we reach concat, then we try with the predicate the value. We apply this, and if it's true, then okay, we find something, so we return a new sum, and inside we pass the value. And if it's false, then we propagate our testing of the value down to the rest of the array. So we'll use here rest first unknown and pass the predicate. So we have this here, and this how can be used. You have like first of none and have a predicate first or none x greater than 3. So this thing should return for some 4, right? Because it's the first that validates this predicate. Now let me try to run that and see that this works properly.